Hi, so this is Mr. Max. What I'm doing here is algebraic fractions. I'm going to do it in 4 parts. So this one here deals with cancellation, which means we are going to have to bring in some rules that we use when we cancel. So the first thing that you need to remember is when you are dealing with algebraic fractions, you must have one term over one term to even consider remotely the chance of starting to cancel things out. So that means you have to factorize the numerator and the denominator if it's already not one single term. And you only cancel where you see a multiplication sign. You also cancel top of the bottom, but it must be joined with times or multiplication sign, as long as there are no pluses or minus in the expressions. And if it's a bracket, you might cancel the whole bracket. You will see exactly what I mean by that. You might not cancel into a bracket. So I'm going to explain this by doing a few questions. Right, so I'm going to get right to it. So this is the first one here. So you've got x squared minus x over x squared minus x squared minus 1 over x squared minus x. So there are two terms on the numerator and two terms on the denominator. So you cannot start cancelling out the x squares, for example. You need to make that one term and also the one under one term. So if you look at the numerator, it's becoming the difference of two squares. And when you look at the denominator, it has a common factor of x. And now that you have done it, you have got one term over one term. You can now cancel out the x plus 1 bracket. And that's leaving you with x plus 1 over x, the x minus 1 bracket rather. So a second one here is 8pq plus 12p square q. Now, when you have two terms, it's either you take out a common factor, all right, or the difference of two squares. Since that is not a minus, we'll take out a common factor. The one underneath becomes the difference of two squares rather. So if I take out the common factor 4p squared at the numerator, I'm going to be left with 2p plus 3q. So I've decided to find 4 is the square of 2 and 3 is the square of 9. So that cleans up nicely to 2p plus 3q and 2p minus 3q. That's the difference of two squares. Now you drop those little squares there. And you can see that the bracket 2p plus 3q is common, so I can cancel the whole bracket because now I have one term over one term, and everything else you just write down and your work there is done. So sometimes you have also a quadratic trinomial like b squared minus 3b, so you need to understand. You factorize the one on top, that is b, outside the bracket, b minus 5. So this is b minus 5, b plus 2. You have to do side work, how to factorize quadratic trinomials. Look at previous videos that I have posted on my channel. So you will realize that b minus 5 is a common bracket or common factor, so you can actually go ahead and cancel that, and then you are left with b over b plus 2, and that is the final answer. All right, let's do a few more. So I have got here 6x squared minus ab minus 15b squared. So I've decided to do this a little bit on the side. All right, so you're looking for, it's a quadratic, it's sort of a hidden quadratic with two squares on both sides. So 6 times negative 15 is negative 90. So you are looking for two numbers, multiplied give you negative 90, and added give you this minus 1 in the middle. Right, so I've just decided to write them down, a few of them. 1 times negative 90 doesn't add up to negative 1. 2 times negative 45 also doesn't add up to negative 1 here. And the same with 3 times negative 30, although it multiplies to a negative 90. 5 times negative 18 also doesn't add up to negative 1. It gives you negative 13. But if you use the numbers 6 times negative 15, well, if you add them, you get, guess what, negative 9. Oh, doesn't work as well. So we have to look for the number. So it's 9 times negative 10. Right, 9 times negative 10 is negative 90, and 9 plus negative 10 gives you negative 1, which is what we are looking for here in the middle. So this is the combination. So I have split then this minus AB with plus 9AB and minus 10ab. So it doesn't matter which one you write first, it will still give you the same brackets. It's just that the bracket, one bracket will be in front, the other one will be behind, but it's still the same thing. All right, I just decided to use the 9 here because it goes with the 6 nicely and the 10 with the 15. They have got common factors there. And also you need to realize that you have two letters AB, so in the middle you must have AB as well. All right, underneath you factor out a 3a, but if you realize there is still 9h squared minus 25b squared is still a difference of two squares. So if I continue that denominator, 3a minus 5b, 3a plus 5b, and then I clean up my numerator, I get to that 2a plus 3b and 3a minus 5b, and then I realize 3a minus 5b is a common factor, so it can therefore be cancelled out. And everything that is left, you just write down as is, and that is the final answer. Right, so we have one more here. So we have got a whole expression that you need to group the numerator. So you take them in pairs. 2a is common here, leaving you with p minus 3q. That same bracket you get when you take out b there. And 10ap plus 8aq, if I take out 2a, I get 5p plus 4q. That same bracket I get if I take out the b in the last two here. Then everything outside the bracket is written in its own bracket, and then you write the other bracket only once. The same applies here, 2a plus b in its own bracket, and then you write 5p plus 4q only once. Well, you can see that 2a plus b is common, one term of one term, so now you can actually start with your cancellation. That leaves you with p minus 3q over 5p plus 4q. I've got one last question where you also have to do the same. So it's grouping because it's 4 terms on the numerator, 4 terms on the denominator. Taking them into pairs, x is common, leaving you with x minus z. Y is common, leaving you with x minus z. And then the bottom here, x is common. Between these two, you have 2y plus z. And z is common, negative z, because it's negative 2yz minus 2z, or minus z squared. So you have to take out the z, and you get 2y plus z. This should be identical. So you write down everything outside the bracket once, and then the common brackets you do write once. The same with the denominator. You realize that x minus z are common brackets or common factors, so you cancel the whole bracket. So everything else, x plus y over 2y plus z, don't need to put them in brackets. That is the final answer.